Hey everyone, I'm Max Clark, and we're going to go down the rabbit hole on interconnection and peering points. First, let's start with what the internet is. So the definition of the internet is a global network of interconnected networks. Wow, global computer network of interconnected networks. Say that 3 or 4 times fast. This will be a little US-centric just because it's easier for the terms, but it applies globally. And the way this works is you start with a network. A network, in this case, let's just use the phone companies and the cable companies. So you've got AT&T, Verizon, Spectrum, Comcast, Cox, etc. And these companies go out and they put cable in the ground or on telephone poles, and they run it to buildings, they run it to houses, and they create a network. And so now we've got an access network. We have a way for a subscriber, whether it's a business or a consumer, to connect to that network and do things with it. Those networks need to interconnect and talk with other networks. So if you were only on AT&T's network, it doesn't really help you because you want to get to other things. You want to do stuff on the internet. You want to talk to somebody who's a Spectrum customer. You want to talk to somebody who's a Comcast customer. You want to talk to somebody who's in AWS or a different data center or in Europe, or you name it, right? So now these networks need to interconnect with each other, and this is called peering. And peering has a lot of dynamics to it. There's a lot of, where we're going to really get into the rabbit hole apparently here on this one. All peering really is at a high level is two networks plug into each other and they interconnect directly, and now they can exchange traffic. At a high level, you've got settlement-free interconnection. So the two networks agree to connect to each other and do not charge each other for traffic to flow between them. And once you do this, now you start talking about business dynamics and geopolitical dynamics and all these other things that come into place, right? These are all the layer 8 issues when you're building and talking about networks on a global scale. And of course, if you're a tier 1 network, you want to be very careful about letting other networks come into the tier 1 club. You want them paying you for access to your network as opposed to you giving it to them for free. So there's a lot of different dynamics of ways that people have done this in the past. What tier 2 networks would do is they would go out and they'd purchase a lot of long haul from a company. And then in exchange for buying a lot of long haul from that company, they would get settlement-free interconnection and peering with that company as part of the deal to make it look like they were a tier 1 network, and you can kind of play the game and do all these different things. Anyways, I'm not going to go down to the layer 8 interconnection peering dispute problem today. So networks have to interconnect with each other, and these happen at peering points, and peering points, for the most part, are carrier-neutral data centers. So these are in facilities that companies like Equinix and Digital Realty and CoreSite and go down the list operate. And I mentioned those ones by name specifically for a reason. In the southwestern United States, you have arguably the densest interconnection point on the planet in One Wilshire. And so now it's actually this cluster of technically 3 buildings that CoreSite's operating, the One Wilshire building, and their data center now at 900 North Alameda, and their LA3 facility, which was built in the parking lot of 900 North Alameda. So we've got CoreSite operating Los Angeles. Digital Realty operates 56 Marietta in Atlanta, which is, if you're in southeastern United States, that's where you're at. The original Miami interconnection point of Napa the Americas, that ended up being purchased and now is an Equinix site. Seattle, a Seattle Weston building, literally it's the Weston building that just happened to have networks come into it and interconnect. Equinix Ashburn, facilities in New York, etc. Geography of these locations and why these buildings happen. Why is it that the One Wilshire building is such a big deal? Why is it that Seattle Weston is a big deal? Why is 56 Marietta? Why is Napa the Americas? Why is, facilities in Avenue of the Americas or Hudson in New York such a big deal? Well, a lot of that's just a fluke of geography, availability, and time. In the United States, we have telecom deregulation happens. It splits up AT&T and breaks into now what we have the regional bell operating companies, or what you hear people talk about in terms of ILEX or RBOX. It's kind of interchangeable with each other. Just comes into. So AT&T gets broken up into the baby bells. The baby bells operate different territories. Deregulation requires that these companies sell access to their networks in a non-discriminatory fashion. So competitors can come up and pay Pac Bell, GTE, AT&T, Southwestern Bell, whoever, right, to get access to their lines. Now, in the case of One Wilshire, for instance, One Wilshire was a building that was 2 blocks south of AT&T's primary switch site for Los Angeles. So if you wanted to get access to that network, well, you needed space, and that site is unavailable to you. So where do you go? Well, you go 2 blocks south to the engineering floor at the One Wilshire building at 624 South Grand that had lots of empty space in the building because it's an aging building. This building was built in the 60s. Newer office buildings have been built. People want to be there. People don't want to be downtown anymore. There's all this other stuff that's going on, and there just happens to be this floor that's completely completely empty, that's available, right? So networks start taking and putting equipment there and interconnecting with each other. Now, this is the Wild West of interconnection days, by the way, where, it's literally like, you would run your own cable, between, locking cabinets and just over the roof. I've got some great pictures of cable mining, of being at the fourth floor of the One Wilshire building, where, if I wanted to interconnect with you, I would just run my own cable and just kind of literally like a ship, like you spoil it up and kind of just toss it over the wall, and then the other side can go and unplug it in, and boom, the networks are connected to each other. So part of it is just, again, Hudson and Broadway in New York, you have buildings that were across the street from AT&T sites that had tunnels between them because of pneumatic tools for Western Telegraph, in order to, and it just happened to be that there was a building across the street and there was a tunnel and there was existing space and really easy to run conduit, and you could just kind of, and like there wasn't all this other infrastructure built out. So boom, that building becomes, goes from being, effectively worthless and not interesting because nobody wants to move into it from a tenant, all of a sudden being the most valuable real estate, on the planet, because it just happened to have this capacity of being able to bring service over to the other side. What makes a building desirable for interconnection, and why do these buildings become where they are? So population centers, if you think about where's the major population centers in the United States, why, so you have population centers, so Southern California. You have the second ingredient, which is access and capacity to networks. So the majority of long haul cable has to have, so you have to have a right of way. Well, what had the right of ways in the United States that was unencumbered? Well, those are train tracks. A network could go to a train, go to the, the railroad and say, we want to put conduit along your rail line. And if you ever are driving next to a train track, look, and you're going to see little orange markers, coming up every X feet. And those are marking a conduit that's carrying fiber optic cable in it. You want a rail hub, you want population center. And then in the case of the coastal, you now start, and you add another dynamic, which is oceanic geography. So in the case of trans-Pacific cables, these cables are coming into two places. They're coming into Grover Beach and San Luis Obispo, and then they're also coming into Seattle. And wow, okay, we might as well just go all the way into this stuff. We're going to really go down the rabbit hole. So the reason why that is the oceanic cable is trenched and buried in underneath the floor, underneath the sea floor, only to a certain point, and then it floats freely. So when you're putting a transoceanic cable in, you want the shortest distance between the points that you're going. You need the proper geography of subterranean flooring, right? So what's the actual, terrain look like is lots of mountains. You have to go up and down. You have fisheries, so you have to deal with fisheries have priority access into areas. You can't run a cable, where crab fishing has taken place, because your cable is going to get pulled up. And by the way, these cables get pulled up all the time, right? This isn't just something that's in the ocean, like never gets touched, right? There's fleets of vessels with submarines that have to go out and find these cables and fix them when they break. And then you want access and in proximity to your major population centers and your interconnection points. So San Luis Obispo, Grover Beach, you can come in and you go to San Francisco and you go to LA, Seattle, Seattle, Miami. Well, what's just south of Miami? Well, the Caribbean and Latin America. So South America, all of the networks that are coming up from Brazil and into Colombia and the Caribbean come up to Miami and then enter the United States. If you're talking about transatlantic cables, Halifax, New Jersey, New York, there's lots of different points where these cables land, and that's also a factor, by the way, of cost, right? How much does it cost you to go out and secure the ability to run a cable up the beach and then in conduit and then to a building, because you need to have a lot of stuff in these buildings. There's some really big networks, and this goes back into like a legacy of the network, right? So Global Crossing and then Asia Global Crossing. Well, Global Crossing started by running cable between the eastern seaboard and Europe, right? So these cables went to London and they went to Amsterdam. So okay, we'll do an example in Europe, right? So major interconnection cities in Europe: London, Amsterdam, Frankfurt, for the most part, and Paris. And roughly on the map, it kind of forms a square, but also when you look at it in terms of like population centers, geographic density, access to cable systems. If you want to have a presence in Europe, what other networks are you trying to interconnect with? Now I'm going to get really corny. I'm going to have some network dad jokes here. At a certain density, then you have the network effect. So once a building crosses a certain density of interconnection, other networks want to go there because that's where everybody is. It's a party. We all want to go to the same place as everybody else because it's a party. It's more efficient for us to be there. And time passes with these things, and then these these buildings get more and more dense. And then we have the birth of the cloud and this concept of the hyperscalers. I hate that terminology, but these like massive deployments, 50 megawatt, 100 megawatt, 200 megawatt of density of, of facilities and campuses. And now you have a different factor that comes in, which is tax incentives, cost of land, cost of electricity. These other costs become drivers. Again, proximity to population centers are still important, but not as important, right? Amazon, AWS launches and is in US East 1 is Ashburn, Virginia. So now we have the DC donut with Ashburn and Reston being the primary locations for most of this cloud-based computing is in these markets. And that was a tax incentive, geography, and cost of power play. This is why markets in Oregon, so outside of Portland, you have Hillsboro, massive data center deployments up there. Why? It's hydropower. It was very inexpensive for them to get land, good tax incentives, and cheap power. And so then you have this like shift, right? There becomes this kind of like magnetic pull with these density of these hyperscale deployments, sucking networks up into those markets and kind of realigning the peering locations. Okay, so that's a lot of kind of background information, but now let's kind of go a little bit farther into this and talk about some crazy dynamics that happen with these things. So peering is not a technical issue. I mean, it is, but it is not a technical issue. It is a business relationship issue. It is a geopolitical issue. It is a contractual issue. There's a lot of other things that come in and fit into the soup that is the layer 8 issues of building networks. And over the years, there's been really funny stories in the peering space, right? Of course, like Cogent being peered and de-peered all over the place, and peering cakes being sent out to other teams of please peer with us, and we love you guys, and can't we be friends, and all these other hijinks that take place. But there's scenarios where, and I'll use Cogent for example. For a long time, Cogent had peering with other networks, but that peering was only in 2 locations. Peering was in Silicon Valley and San Jose, and on the East Coast. So if you were in Los Angeles and you were a AT&T customer in Los Angeles and you needed to talk to a Cogent customer in Los Angeles, you weren't connected directly to each other in Los Angeles. There was no interconnection of those networks. That network was hopping up to San Jose and then coming back down to the other network and back and forth. And that doesn't seem like a big deal. Latency is relatively low, but it introduces this other dynamic with the internet that decouples geographic proximity to actual network performance and speed. So that's a simple example I've given you in terms of 2 networks in Los Angeles going up to San Jose and back. We see this in lots of different markets. So for instance, geopolitically, there's lots of reasons why certain networks in different countries can't peer with each other in region, and they have to go to a different market in order to interconnect with each other. There's a lot of geopolitical dynamics with that one. Now, if you're talking about transversing some sort of body of water, capacity constrained typically, and also much higher latency or longer time to transit and to talk to each other. So these become not ideal network scenarios. Other good example that we dealt with for a long time, Brazil. You could have networks in Brazil not want to talk to each other in Brazil because of course they want to charge each other and who's the better one and who's bigger and who's not. And so instead of being able to interconnect in Sao Paulo or Rio de Janeiro in Brazil, these networks are coming up to Miami and interconnecting with in Miami. Or if you're trying to gain access to customers on those networks in Brazil, instead of going and spending a fortune to be in Brazil, in Rio or Sao Paulo, you put your equipment in Miami. You can now take circuits and purchase capacity from your main networks of choice or destination networks out of Miami. And by the way, now you're not in the Brazilian market, you're in the US market. It's much cheaper to buy these things because there's a lot of competition in this Miami data center. So you get a better rate. And lo and behold, guess what? Even though you're hopping down, the ocean from Miami to Brazil, it's still faster than being in Brazil, because if you were in Brazil on one of these networks, maybe you're going to Miami and then back to Brazil anyway. So you're just cutting your time and you're increasing you're doubling your speed. So these sorts of dynamics make a very interesting thing when you start talking about building and how do you structure and how do you deal with networks in general. And there's a lot of things that as a network engineer and architect can do and start thinking about these things on global scales. And examples are like I just gave. Do you need to put equipment in market, in country? Can you take and interconnect with that network out of market in a place that's more favorable to you from a cost structure, from a proximity structure, from a geopolitical structure, whatever it may be? Do you want to have equipment located in Asia and be connected to a network in Asia, or do you want to interconnect with that Asian network in the Western United States or whatever? Same thing in Europe. Where is the best geography for you to put your equipment? Now, there's one of the layer 8 issues that now we get to deal with a lot, and we talk about is Nexus. And Amazon is famous for dealing with Nexus for a long time. And if you go read Brad Stone's book, he talks, gets into this and talking about, what Amazon had to do to avoid paying sales tax. And for a long time in the US, sales tax was, if you had a physical presence in the state, you had to charge sales tax in the state. If you didn't have a physical presence in the state, then you didn't have to charge sales tax in that state. And technically the customer is supposed to pay the sales tax for the stuff that they bought. And this went on for a long time, and then it finally became equalized, and now sales tax is collected everywhere. But every time a municipality, a city, or a state kind of get into financial trouble, right? What do they need to go out and do, right? They immediately start talking about how do we raise revenue, aka how do we increase taxes? Well, how do you increase taxes without increasing taxes in a way that people aren't going to perceive it as increasing taxes? Well, you try to go after the businesses, or you try to not go after consumers directly. And so now with Nexus, we deal with these issues. And Chicago was the one that created this terminology, and it's just so incredibly epic from a political standpoint of unpossessed property. Seriously, there is a tax on unpossessed property in Chicago, and other places and other municipalities are following suit with this one. And so the unpossessed property tax says something along the lines of like, if you are a Netflix customer and you're in Chicago, you now have unpossessed property in the form of the Netflix subscription and digital library, and so therefore you have to pay taxes on that unpossessed property. So that becomes also this other thing that gets kind of like poured into this like soup and swirled around in terms of a placement. Because if you want to build a data center out and you put equipment in the wrong location, all of a sudden are you open, and yet you don't buy the equipment, you ship the equipment, but that equipment gets UCC'd. Municipality's going to know that you're there because they see you on registrations. Now you have to pay taxes on that. Are you going to open yourself up to different business taxation issues? So, there's certain places you want to stay out of. Again, now we start talking about other factors of data centers, right? Data centers in Chicago versus data centers outside of Chicago. It is very popular for data centers to exist outside of Chicago and the city limits for these reasons. And then, again, gravitational pull, as more networks are there, more networks start to congregate, and you've got this network effect that applies again. So interconnection is a fascinating thing, and there's a few networks that are on the market right now that tout like, hey, we just opened another location right in this market in the city, and people are like, hooray, it's so wonderful, we're in the city. And it's great marketing, and in some cases it's fantastic, but in not every example is it the great benefit that you deal with, either that you would expect it to be. For instance, if you see somebody open a data center in San Diego, San Diego to Los Angeles is, what is it? It's about 200 miles. So, but in between, roughly in between San Diego and Los Angeles is Irvine, and Irvine is a really dense data center market in SoCal. So call it 100 miles between Irvine and San Diego. That distance in network isn't very far. It's very fast. So you're going to see marketing people talking about like, edge. I don't even know what edge is, but edge. We need sub microsecond latency, and you have to be in market in order to do it. But that's not the case for most applications. If you're processing credit cards, for instance, is your customer at your point of sale terminal in your store going to notice a difference between, 2 milliseconds, 5 milliseconds, and 10 milliseconds? I mean, the answer is absolutely not. Like, you're not blinking at that speed. So from a network deployment strategy, do you need to physically put equipment in San Diego, or do you just need to be in Irvine or in Los Angeles and be interconnected with the networks up in LA or Irvine? And in many cases, just saying, hey, San Diego is AT&T country for phone systems, for the phone, and it is Cox? It's Cox for cable. So if you go and get an AT&T connection and a Cox connection, either Irvine or Los Angeles, you have a nominal increase in latency or time for network to track, and that's probably perfectly acceptable to you. Where there's a good example I thought of earlier, and I didn't wedge into this one, which is traffic distribution. There's really, call it two large-scale ways of doing traffic selection and distribution if you're a website operator or a CDN operator. Maybe those make more sense. A CDN is a content delivery network. If you're not familiar with it, what it is it's a company that has servers all over the planet, and websites can use them to be closer to their customer and have more capacity. One of the first ones in the market that you may or may not know is Akamai. We have companies now today, Limelight, CloudFront's AWS, Azure runs their own, Google runs their own with GCP, Fastly is a great CDN, Limelight, Cloudflare technically is a CDN. All these different things come into it. So now the example here is if I go to a website What's a good website? I'll just use my name. If I go to maxclark.com, right? And on that website, I have images or videos or I have whatever it is. Instead of serving those images and videos off of my server, I can serve them off of the CDN. Browser makes a request and says, hey, I need to go to images.maxclark.com, grab this picture of my face smiley. In order to do that efficiently, the first thing that needs to happen is it needs to figure out, how to get to what's the closest server in the CDN. Because it gets kind of like, it's counterintuitive. If I'm in, Dallas, I don't want to end up in a server in South Africa, right? That's against the point. Diminishing returns. Not diminishing returns. It's like actually creates a big problem. So how does that happen? Well, the way it happens is really one of two things, right? So either we have, my browser does a DNS lookup. And DNS lookup just says, hey, give me the IP address for images.maxclark.com. That resolves to an IP address, and that IP address then can be routed on the network, on the internet between my computer and wherever the server actually is. We have a technique called BGP Anycast, and BGP Anycast is the network operator can advertise that IP address in multiple places at the same time. And the networks themselves are designed in the way the routing protocol and the way BGP works, it is looking for the shortest distance, the shortest path. It doesn't know distance. It just knows like how many devices do I have to go between A and B in order to get to this destination. Okay, that's not how many networks do I have to go between point A and B in order to get to this network. So BGP Anycast lets you advertise that IP address from multiple places at the same time, and you don't really know distance, but you do know there's less hops, there's less ASs between A and B, there's less networks between A and B, and take that route. If you ever played Marco Polo, imagine being in the pool and you say Marco, everybody in a circle around you says Polo, right? Well, you're going to listen to the one that's closest, that feels closest to you, and you're going to go that direction. That might not be closest to you because they might just be louder than everybody else, and you just hear them better. So that's the way you go, but it's not necessarily ideal. The next way that you do this is with DNS, using DNS. And so the DNS server looks at your IP address. In this case, it's not looking at your IP address. It's looking at the DNS server that you're using's IP location. And it's making a decision, hey, this server's here, so therefore send them to this location. Quirks and oddities. When OpenDNS launched and started with their recursive DNS service, which is totally simple idea, but man, did it change the world. If you were in Los Angeles, well, OpenDNS's servers weren't in LA, they were in San Francisco. So if you were if you were trying to use a CDN that was using DNS to make the traffic steering decisions, and you were in LA where you were hitting this OpenDNS infrastructure in San Francisco, you were getting CDN nodes in San Francisco as opposed to CDN nodes in Los Angeles. Again, not a lot of distance, 8 milliseconds, not a huge deal, but little quirks like that become an issue with network capacity planning and actual performance. So these networks have to get denser and denser and denser and denser and denser. And they start with the major markets first, and then they go to the secondary markets, and they go to tertiary markets, and they kind of keep building based on what capacity needs actually are. So there's a lot to unpack in that. It was a lot of rambling on my part this morning. Basic point with this thing is the network is an incredible thing. And if you're ever in a conversation with somebody and they're trying to tell you, we have a lot of customers in some market. We have a lot of customers in Augusta, Georgia. We need to go put servers in Augusta, Georgia in order to service those customers in Augusta, Georgia. All I want you to remember is maybe not. The chances are you actually don't need to do that. And doing that's going to be counterintuitive. Right? You should be looking at, is there a CDN that's close? What networks are they actually on? How are they accessing your network? And we'll make more extreme examples. We need to have equipment in China. Do you? Maybe you don't. We've got lots of clients. We did not deploy their infrastructure in China, and they found that they could improve their user experience by not doing that and not having duplications of infrastructure across the ocean in a different country. Make your operations a lot simpler. Anyways, I'm Max Clark. That's a quick down the rabbit hole on interconnection and peering and the dynamics of how these networks work.